you were watching me? But I was not actually touching anything. Nobody has. Not you, not me, not anyone ever. That is not a riddle, that is not philosophy, that is physics, and it is about to completely change how you see the world around you. Because the moment you understand what touch actually is, you will never look at anything the same way again. Let's find out what is really happening here. When we hear the word touch, we usually think about direct contact. Touching a wall, holding a mobile phone, hugging someone. That is how human perception understands touch. But reality may be very different. What if I told you when you touch an object, you are simply being stopped from crossing its boundary? Every solid object creates resistance against your body. And this raises a strange question. What is really happening when two objects touch? Sounds confusing? Don't worry. Physics is at your doorstep. Let's understand the illusion of touch. We classify matter as solids, liquids, and gases based on how we interact with it. Solids strongly resist us, liquids flow, and gases are difficult to feel directly. So naturally, our intuition tells us that touching means direct contact. But physics challenges that intuition. Physics asks a deeper question. What is actually happening at the atomic level? Objects do not behave the way our brains imagine at the atomic level. When my hand approaches this mic, the atoms inside my hand never truly merge with the atoms inside the mic. Instead, invisible electromagnetic forces begin pushing against each other. And to understand why that happens, we first need to understand the atom. As Richard Feynman wrote in Feynman Lectures on Physics, all things are made of atoms. Little particles that move around in perpetual motion, attracting each other when they are a little distance apart, but repelling upon being squeezed into one another. Everything around us is made of atoms. Our bodies are made of atoms. The microphone, the camera, the wall, the water, and even living cells all are built from atoms. Most people visualize the atom using the solar system model. The nucleus in the center, like sun, and electrons move around it like planets. This model helps us to visualize the atom. But the actual structure is far more complicated, almost like a blurry, shining cloud. An atom consists of positively charged protons, negatively charged electrons, and neutral neutrons. As we know, opposite charges always attract each other, and similar charges always repel each other. So this interaction of charges is called electromagnetic force. According to scientists, atoms mostly consist of empty space. Then why can't we pass through matter? Well, here comes the misconception. Empty space does not mean nothingness. Electrons do not move around the nucleus in neat circular paths like planets. Instead, electrons exist in probability regions called electron clouds. That means we cannot know their exact position at all times. I know this part sounds a little confusing, so let's understand it with simple real-life example. Imagine a fan. When the fan is off, you can clearly see the blades, but when it spins very fast, the blades become blurry and look like a foggy circle. Similarly, electrons behave so unpredictably that we describe them as clouds of probability rather than tiny fixed particles. Now from this point on, the definition of touch changes. What we feel as touch is actually the repulsion between electron clouds of two objects, and this repulsion is called electromagnetic repulsion. However, electromagnetic repulsion is not the whole story. There is another deep law of physics working behind the scenes. It is called Pauli exclusion principle. It states two identical electrons cannot occupy the exact same quantum state at the same time. In simple terms, every object's electrons have their own states, and those states cannot simply overlap. Let's simplify it with example. Imagine you and your friend deeply enjoying a conversation. Suddenly, someone interrupts your conversation, your mood, and your vibe. Naturally, you would resist that interruption. In the same way, electrons resist having their fixed states disturbed by the other electrons. Combined with electromagnetic repulsion, this principle prevents matter from collapsing into itself. Even after all this explanation, one question still remains. Is there any possibility that a human could pass through a wall or any other solid object? before you say no, let me clear it up first. Quantum mechanics introduces a phenomena called quantum tunneling. Quantum tunneling means tiny particles like electrons sometimes have a chance of crossing barriers and appearing on the other side. But this only works for extremely tiny particles under very specific conditions like thin barriers, appropriate energy conditions, and wave-like quantum behavior. A single electron may tunnel, but our bodies consist of billions upon billions of atoms all interacting simultaneously. Because of that, the possibility of an entire human body tunneling through a wall or any other object becomes essentially impossible in reality. So practically speaking, it is not possible. Humans are neither ghosts nor tiny electrons. Let me share an interesting fact with you. Some ghost-like particles can actually pass through matter almost effortlessly. And it is real, it is not science fiction. These particles are called neutrinos. They can pass through walls and enormous amounts of matter because they interact very weakly with atoms. In fact, what if trillions of neutrinos are passing through your body right now at this exact second without you feeling a single one? It is unbelievable even though it is true. In the end, I would like to say that our brains evolved for survival, not for understanding the atomic reality. Our senses give us a useful version of reality, not a complete one. Your brain interprets resistance as solidity, electromagnetic interaction as touch, and boundaries as physical contact. That interpretation helps humans survive and navigate the world. However, behind the everyday experience of touch, the reality is shaped by invisible forces, probabilities, electron clouds, and quantum rules. Science is not only about invention and discovery, it's also about fascination. And honestly, this video started with a simple question: what does it actually mean to touch something? But the deeper I searched for the answer, the stranger everything became. And now you probably understand why. So if you enjoy these kinds of questions that completely change how you see everyday life, leave a like, subscribe, and hit the bell icon for more fascinating facts. I'll see you in the next mystery.